Hi everybody, let's look at section 4.6 where we're solving logarithmic and exponential equations. In this section you're going to want to utilize a lot of the material that we learned so far, especially the properties of logarithms. So to solve this first example, we have log base 3 of 4 equals 2 times log base 3 of x. There's lots of different ways that we can approach this, but one of the benefits to this problem is that if we have a single log on each side, or as we'll see in the next example, if we can write the expression on one side as a single log and we have another log on the other side, there's a couple of ways that we can approach this. So to begin, we still want to using the properties of exponents, bring this 2 to the exponent. So I'll have log base 3 of 4 equaling log base 3 of x squared. So one of the things that we can do is we notice that the base is 3 for the logarithm, and I'll 3 to the on both sides. Similar to what we do on one side, we're doing to the other. Now the left side is going to evaluate to 4 using the properties of exponents, and the right side, log base 3 to the log base 3 of x squared is x squared. Let's finish this problem. We're going to square root both sides, getting us x equals plus or minus 2. Now, before I show you the other example, we have to be a little cautious here. The domain of a logarithm is x is greater than 0. And we have to note that if x is -2 and we plug this into the original equation, we're going to see that we get log base 3 of -2, and that's something that we cannot evaluate. So the answer is x equals 2. Okay, so another way that we could have approached this problem is when we have exactly 1 log on the left and exactly 1 log on the right, essentially what happens is that we can drop the logs. So we get 4 equals x squared. So you might have seen the property, if you have x equaling y, then you can log both sides, right? And so this goes both ways. If you have logs on both sides, it means that it's going to essentially be the arguments. And so you'll still end up getting to the same result. And one of the things that I know when I was learning about logarithms is that there's so many different ways that you can think about this, but I'm going to do my best to show you those different ways so that you can pick one that you're latching onto that's most comfortable for you. But I also just feel like you're seeing it different ways helps get a more global understanding. Alright, so I'll see you in another video.